Today we're going to solve one of these exercises of projectile motion, this time with the exercise 27 from our book College Physics. And it says, a ball is thrown horizontally from the top of a 60-meter building and lands 100 meters from the base of the building. Ignoring the resistance, how long is the ball in the air? Let's focus on part A first of all, and then we will try to solve the other parts. Vamos a resolver la parte A. El ejercicio nos dice una pelota es arrojada horizontalmente desde la punta de un edificio que está a 60 metros de altura y aterriza o cae a 100 metros de distancia de la base del edificio. Ignore air resistance. So let's take our exercise to our blackboard. There it is. And the first thing you have to do in this kind of exercise is settle a convenient system of reference. And for that, well, I have brought my ball here, but I won't put it here in the origin because it will be very, very uncomfortable since the ball will fall to the negative part of the y-axis. ¿Por qué no voy a poner la pelota aquí en el origen, en 0, 0? Porque a partir de que empiece a caer, lo va a hacer para el lado negativo del eje de las Y. That will be very uncomfortable. Instead of that, I'm going to place the ball right here at 60 meters above 0. Let's suppose that here it's 60. In fact, there are 6 little squares from the origin. 6 little squares, yes. And let's consider that this will be the top of the building. Vamos entonces a poner a la pelota no en el origen, sino a 60 metros de altura del punto origen, el punto 0, 0. Let's remember that this is the y-axis and this is the x-axis. Besides, the ball will fall 100 meters from the base of the building. It will be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 meters right here. There it is. Once again, why didn't we put the ball here? Because it will fall to the negative part of the y-axis and that will be very uncomfortable. And well, I'm gonna draw a trajectory of the falling ball. It will be something like this, and it will fall right there. Okay, that's not the correct draw, but it's an estimated draw. Now, the second thing that you have to do for this kind of exercises is calculate the horizontal and the vertical components. So let's do it, and let's start with the horizontal component of the initial velocity. That will be Vix, or horizontal component of the initial velocity, equals to the initial velocity times the cosine of the angle. But something really strange is going to happen here, because we don't have, in fact, the initial velocity. It's not there. Nobody has given it to us. Nadie nos ha dado la velocidad inicial. Nevertheless, that doesn't mean that it's impossible to calculate the horizontal component of the initial velocity. Let's try to focus on the things that we have. We don't have the initial velocity, but we have the angle. It's not there given in numbers, but it's there given in words, because the ball is thrown horizontally. Ya que la pelota fue arrojada horizontalmente, el ángulo de tiro de la pelota fue de exactamente 0 grados. So we do have the angle, but not in numbers. We had it literally. So, well, we don't have the initial velocity. That doesn't mean that we can go on. But I'm going to replace here the angle by 0 degrees, the cosine of 0 degrees. And the cosine of 0 degrees, it's 1. So I'm going to write here V initial velocity vi times 1. And 1 multiplied by anything, it's going to be the same thing. Initial velocity multiplied by 1, it's initial velocity. Okay, we haven't found nothing here. There is nothing that we have found here. No hemos encontrado nada, absolutamente nada. But we could see that the angle was 0 degrees, and let's see if with that angle we can do something more with a vertical component. Maybe we can get more information from here. So the initial vertical velocity, it will be equal to the initial velocity times the sine of the angle. Once again, the angle is equal to 0 degrees. We don't have the initial velocity, but that doesn't matter. We can go on with the exercise. A pesar de que no tenemos la velocidad inicial, eso no importa. Podemos seguir con el ejercicio. I'm gonna write here the sine of 0 degrees, and the sine of 0 degrees is equal to 0. So I'm going to multiply the initial velocity, whatever its value is, because we don't know it, multiplied by 0. And 0 multiplied by anything is going to be a 0. This time I'm going to write 0 meters per second, because we are calculating, after all, a velocity, and the velocity is measured in meters per second. Ok, 0 multiplicado por cualquier cosa nos da 0, y la velocidad inicial vertical va a ser 0, 0 metros sobre segundo, porque la velocidad se mide en eso, metros sobre segundo. What is the meaning of this? Because we have found a number here. What is the meaning of that number? Well, that means that only for that instance, the instance of the throwing of the ball, the vertical velocity will be 0, because they're not throwing the ball upward, neither downward. They try to throw it horizontally. The ball falls down, that's quite clear, but the initial thrown was horizontally. El lanzamiento inicial fue horizontal, no fue ni hacia arriba ni hacia abajo. Que la pelota terminó cayendo, eso sin duda alguna, lo hizo porque está bajo el efecto de la gravedad, pero el lanzamiento inicial fue horizontal. Por ende, solo por este breve instante, el componente vertical de la velocidad inicial es 0. ¿Por qué? Porque no la arrojaron ni hacia arriba ni hacia abajo, totalmente horizontal. Entonces, solo por ese breve instante, la velocidad inicial vertical es 0. We don't have too much data here, and so, well, we calculated the first two things that we have to do. Well, in fact, we calculated the horizontal component, we calculated the vertical component, and we set a graph. Establecimos un sistema de referencia, un gráfico. Tratamos de calcular los componentes horizontales, no llegamos a nada por ahí. Tratamos de calcular el componente vertical de la velocidad inicial y llegamos a 0. With that data, would it be possible to answer part A? Okay, let's take a look at part A. Part A, it says, how long is the ball in the air? When they saying, or they asking how long, they're talking about the time. So we need to find the time, given the initial vertical velocity and this height. Would we be able to find it? Let's find it out. Vamos a ver si con tan pocos datos podemos encontrar entonces cuánto tiempo va a estar la pelota en el aire. Entonces, vamos a nuestra hoja de fórmulas. Here we have it, but first of all, let me change the color here, and let's ask to every formula if it's going to be useful or not. Okay, first formula. Horizontal motion. We have the final position in x, which it is 100 meters. We have the initial horizontal position, which is 0 meters. We considered the base of the building in 0. We don't have the initial horizontal velocity, and we don't have the time. So this formula won't work for us. Esta fórmula aquí no nos va a servir, porque no tenemos ni la velocidad inicial horizontal ni el tiempo. So, go away. Let's try to use another formula then. What about for the vertical motion? Okay, we don't have the final vertical velocity. We do have the initial vertical velocity. We just calculated recently. It was 0. We have the gravity, but we don't have the time. Another formula that won't work for us. What about the third formula? We have the final height, which will be 0. Let's remember that the ball will fall down to the ground. If it falls to the ground, the final height is 0. Recuerden que la pelota llega hasta el suelo, por ende la altura final es 0. We have the initial height, it's the top of the building, 60 meters. We have the initial vertical velocity, which is 0. We don't have the time. We have the gravity, and once again, we don't have the time. There is only one unknown here, precisely the time. Tenemos solo una incógnita aquí, es precisamente el tiempo, the one that we need. So the formula that we are going to use is this one. Let's take it to our blackboard. There it is. Okay, now let's start replacing all the data that we need. Okay, let's start with the final height. The final height, it will be 0 meters. Meters is equal to the initial height, which is equal to 60 meters, plus the initial vertical velocity, which is equal to 0 meters per second, times the time, plus the half of the gravity, which is equal to minus 9.8 meters per squared seconds, times the time squared. There it is. So let's try to isolate the unknown t, the time. Okay, I'm going to start sending that 60 meters to the other side as negative. It will be 60 meters negative equals to, okay, what will happen with the second term? It's really interesting because in the second term we have a 0 multiplying the time. 0 multiplied by t or whatever it is, it's going to be 0. All of this term will be cancelled. Todo ese término se puede cancelar de una vez porque va a dar 0. Un 0 que va a terminar sumándose con el tercero término y no va a afectar. 0 sumado o restado no afecta en nada. By the way, I forgot to put here a negative. Okay, the half of 9.8, it is equal to 4.9. A negative and positive multiplied by negative, it's negative. 4.9. By the way, I forgot to put here meters. Minus 60 meters. Minus 60 meters equals to minus 4.9 meters per squared seconds times the time squared. Now, that minus 4.9 meters per square seconds is multiplying the time, so it must go to the other side to divide. Minus 60 meters divided by minus 4.9 meters per square seconds. I must not forget the meters here. I don't know why I'm forgetting that, but it's not a big deal. Okay, not at the moment. Okay, equals to t squared. Okay, by the way, I'm going to draw a little line here so we don't confuse the x of the x-axis as part of our exercise. Alright, now we must divide 60 by 4.9, and that's equal to 12.24. what is going to be the unit? Okay, meter goes with meter, and what it remains is squared seconds. But we haven't isolated this time, at least not yet. Alright, I ran out of space here. I will move these right here. And to isolate the t, I must send that square to the other side as a square root. The square root of 12.24 squared seconds. And the square root of 12.24 is equal to 3.498. Let's assume it as 3.5. That would be enough. 3.5 rounded. I will put it right here. T is equal to 3.5. 3.5 is equal to the time. There we have it. And finally, we could find the time. Awesome. Alright, now we must go on with part B and C and D. Okay, I was having some technical problems there, but I'm back. Alright, let's try to solve that part here. Okay, but before that, we must calculate what must have been the initial horizontal component of the velocity. ¿Cuál debió haber sido entonces el componente inicial el componente horizontal de la velocidad inicial? Ok, eso lo hubiéramos podido responder aquí, pero no encontramos nada. So what can we do? Okay, let's remember that at this moment we have the initial vertical velocity and also the time. So with that, let's try to calculate the initial horizontal velocity. So let's go back to our formula chart and let's start as always with the first formula. Okay, and we have the final position, which is 100 meters. The final horizontal position, sorry, I made a mistake here. I do have it. Okay, and we have the initial horizontal position, which is 0, but we don't have the initial horizontal velocity, but I have the time. So with this formula I can calculate the initial vertical horizontal velocity. So let's take it to our blackboard. And there it is, but I don't need it here because I'm gonna do it right there. Okay, part B. The formula that we need to use is this one. Alright, let's remember that our unknown is the initial horizontal velocity. Recuerden que nuestra incógnita es la velocidad inicial horizontal. For that we need to isolate it. So let's do something. I'm gonna send that initial position to the other side from positive to negative. And in this side it remains the initial horizontal velocity times the time. That time it's multiplying, so it goes to the other side to divide. The final position, horizontal position, minus the initial horizontal position divided by the time is going to be equal to the initial horizontal velocity. There it is. Now we have to replace all the data that we have. The final position, let's remember, the final horizontal position is 100 meters. So I'm going to write here 100 meters minus the initial horizontal position, 0 meters. Let's remember that our building is at the beginning of the x-axis, 0 meters, divided by the time, which is equal to 3.5. I think it is 3.5. Yes, it is 3.5 seconds. I forgot to put here seconds. Okay, 3.5 seconds. that's equal to the initial horizontal velocity. 100 minus 0 is going to be 100 meters, and that divided by 3.5 seconds is going to be equal to, let's see, 100 divided by 3.5, 28.57. 28.57 meters per second. And that's the value of the initial horizontal velocity. We couldn't find it at the beginning, but after all, we did. No pudimos encontrarla al principio, pero después de todo, sí que la pudimos encontrar por otro lado. Now, we must answer part C. Part C says, what is the vertical component of the velocity just before the ball hits the ground? Okay, don't forget that we already have a vertical velocity, but this one is the initial vertical velocity, and they're asking us about another velocity. In this time, they're asking us about the velocity just before the ball hits the ground. Entonces, ¿qué es lo que vamos a hacer para encontrar esa velocidad? La velocidad en la cual la pelota está a punto de alcanzar el suelo. Okay, for that, let's use all the data that we have. The initial vertical velocity, this time, and we're going to use this time because the time just before the ball hits the ground, it will be like 3.4 seconds, but the difference in the velocity won't be too much. Si agarramos 3.5 segundos como el tiempo, va a estar prácticamente que bien, porque la velocidad, si agarramos 3.4 segundos, que es justo antes que la pelota impacte el suelo, la diferencia de la velocidad no va a ser mucha. Así que para no complicarnos, vamos a usar 3.5 segundos como el tiempo. Bien, recuerden que estamos tratando de calcular la velocidad justo antes que la pelota toque el suelo. ¿Ok? Entonces, agarrar 3.5 segundos no va a afectar mucho los cálculos. Ustedes pueden agarrar 3.4 segundos, 3.49 segundos si se les antoja, pueden hacerlo. Yo lo voy a hacer con 3.5 para hacer las cosas más fáciles. Tenemos eso, and we also have the initial horizontal velocity. And let's remember, we need to find the final vertical velocity. Okay, so let's go to our sheet of our chart of formulae. And from the beginning, as always, okay, let's see. We have the final position, we have the initial horizontal position. Now we have the initial horizontal velocity, and we also have the time. But this formula has it all, and that means that is useless for all, because we're trying to find something. In this case, the initial vertical velocity, and we don't have any vertical velocity in this formula. We only have a horizontal velocity there. Okay, what about the second formula? Okay, we need to find the final vertical velocity, so we don't have it. We have the initial vertical velocity, we have the gravity, and we also have the time. So we have everything here. Well, not everything, in fact. We need to find a final vertical velocity, and this is the formula that will help us. And it's wonderful because we don't need to isolate anything there. No hay que despejar nada allí. So let's take it to our blackboard. And there it is. Okay, I need it here. Don't forget, this is the part C of our exercise. Let's see, and here it goes. The final vertical velocity, it will be equal to the initial vertical velocity. How much was it? 0 meters per second. Oh, sorry, I did something that I shouldn't. The initial vertical velocity, it's right here, 0 meters per second. So I write 0 meters per second. Plus the gravity, minus 9.8 meters per squared seconds, times the time, which we're going to assume as 3.5 seconds. It's right here, so let's take it. 3.5 seconds. Alright, the final vertical velocity, it will be equal to 0 meters per second plus, oh, by the way, positive multiplied by negative, it will be negative. Negative multiplied by positive is going to be negative. Okay, 9.8 multiplied by 3.5, it's equal to 34.3. What is going to be the unit of this? Okay, 1 second goes with 1 second, but because there was 1 second below, there will be 1 second after all. And a 0 minus 34.3, it's equal to minus 34.3. Okay, what is the meaning of that sign? Well, it means that at that moment the ball is going downward. ¿Qué significa que haya dado negativo? Que para ese momento, en el momento justo antes de impactar el suelo, la pelota está yendo hacia abajo. Fíjense que de hecho la velocidad inicial horizontal dio positivo, porque según establecimos en nuestro sistema de referencia, la pelota está yendo hacia la derecha, pero verticalmente está yendo hacia abajo. Entonces, con eso ya tenemos casi todo, nos falta encontrar la parte D. So, what does the part D says? What is the velocity, including both the horizontal and vertical components of the ball just before it hits the ground? ¿Qué es lo que nos están pidiendo aquí? Hallar la velocidad, incluyendo la horizontal y la vertical de la pelota justo antes que impacte el suelo. What do we have to do? We have to find a formula that includes both horizontal and vertical components of velocity at the same time. Necesitamos buscar una fórmula que involucre o que incluya al componente horizontal y vertical de la velocidad al mismo tiempo. Is there any formula like that? Yes, it is, but we need to find it. So we're going to solve that right here, and let's go back to our chart of formula. Okay, I almost forgot to do something. No, it's okay. Yeah, okay, let's remember we need to find two velocities, horizontal and vertical. In the first formula, we only have an horizontal velocity, so this formula won't work. We also need the vertical velocity. Here we have two vertical velocities, so this won't work either. What about this one? Okay, once again we only have one kind of velocity, vertical velocity. We don't have the horizontal. Here we have two velocities, but one is final and the other is initial of the vertical velocity. Aquí teníamos dos velocidades, pero una es la horizontal y la otra, una es la final y la otra es la inicial de la misma cosa, la vertical. Necesitamos las dos, vertical y horizontal. So we haven't found it yet, we must keep searching. Okay, what about here? Let's see. Distance from the starting point at any moment. Is there any velocity here? No, it isn't. So it won't work. Angle of the position at any moment. Is there any velocity here? No, there isn't. So it won't work. Velocity at any moment. Okay, let's take a look. Here we have a vertical velocity and we have an horizontal velocity and a vertical velocity. So this is the formula that we are looking for. Esta es la fórmula que estábamos buscando. Así que vamos a usarla. So let's take it. As you can see there, here it's just a velocity. This is the velocity at any moment. Just velocity. That includes vertical and horizontal velocity in that formula. Okay, let's take it there. Here we go. And let's try to calculate that velocity at any moment. In this case, the velocity just of the ball just before it hits the ground. Vamos a ver la velocidad a secas, no ni horizontal ni vertical, de la pelota justo antes que impacte el suelo. For that, we need to review something. Let's remember that when you throw with a certain angle something, it has three kinds of velocity, we can say it that way. We have the vertical velocity that we have calculated before. We have the horizontal velocity. This one is a horizontal velocity, but we also have a vertical velocity, which acts according to the laws of gravity. Esta actúa de acuerdo a las leyes de la gravedad. La otra es constante, y tenemos una velocidad secas, que es la combinación de tanto la horizontal como la vertical. Es el fruto de la interacción entre esas dos velocidades. Esta es simplemente velocidad a secas, fruto de la interacción entre las otras dos velocidades. Okay. The first thing that we have to replace in that formula, it will be the final horizontal velocity. Do we have it? Okay, let's take a look, because here we have the initial horizontal velocity, but we don't have the final horizontal velocity. But don't worry about that, because according to the laws of gravity, and I also wrote it here, I pointed out here, and for the horizontal motion, which is constant, we have this equation, and that means that the initial horizontal velocity will be equal to the final horizontal velocity. It will be the same at any moment. La velocidad horizontal siempre va a ser la misma en cualquier momento, al inicio y al final, porque no hay ninguna fuerza que la esté empujando ni hacia adelante, o mejor dicho, ni hacia la derecha ni hacia la izquierda en este caso. Entonces, si ya tenemos la velocidad inicial horizontal, nos va a servir también como velocidad final horizontal. With that, I'm going to replace here that number, 28.57 meters per second. Squared plus the final vertical velocity, which we have right here, it's equal to minus 34.3 meters per second. 34.3 meters per second squared. Oh, that square root wasn't long enough. There, better. Okay. Now, let's try to solve this. If we calculate all of that, the answer will be 44.64 meters per second. And with that, we have solved part D. And that's all. Always remember, try to take a look at all the formula and to see what do they have to offer, and how they can help you. That's what you have to do at any moment of the exercise. En cada parte del ejercicio siempre vayan a la fórmula, al formulario, y vayan preguntándole a cada fórmula qué tiene cada una de ellas para ofrecer, basados también en lo que ustedes ya tienen, y van preguntándole qué pasó al principio, que no pudimos seguir. Está bien, no pudimos calcular el componente horizontal, sí pudimos calcular el componente vertical, pero eso no quiere decir que el ejercicio vaya a parar allí. Con eso poco que tenemos ya podemos irnos a nuestra hoja de fórmulas e irle preguntando a cada fórmula qué es lo que tiene para ofrecer basado en lo que nosotros ya tenemos. Son ejercicios que hay que abordar con calma, pensándolo bien parte por parte, y con las fórmulas en mano podemos calcular todo lo que nos están pidiendo. That's all for this video. I hope you could understand it, and don't forget to give me a thumbs up, and I'll see you in the next video. Bye!